Always waiting for that delay. All right. Well, hey, everyone. Welcome to the Weekly Space Hangout for Friday, January 16th, 2015. I'm Fraser Cain, publisher of Universe Today, and this week we've got Dr. Brian Koberlein.
Hi, everybody.
Brian, can you hear me?
I should be able to. Yes, I can hear you.
Awesome. Perfect. And I can hear you.
Okay.
It worked.
Then there we are.
All right. We've got Dave Dickinson in freezing cold Maine.
Northern Maine, staying warm. I'm literally blogging from a basement now. How cliche is that?
And we got Morgan Rehnberg. Hey, Morgan.
Hey, Fraser.
So just to warn you folks, I'm in a hotel in New Orleans, and I don't know. The Wi-Fi has been pretty good. I don't know how I'm coming through for you guys right now.
Looks good.
Pretty well.
Yeah, looks good.
Well, okay. Yeah, no, I did a bunch of speed tests, and I couldn't believe it. I was like ready. I was like, we're gonna have to cancel. This isn't gonna work. And then I did a bunch of speed tests, and I was getting really fast speed. So I think we're all right. Cool. So this week we're going to be talking about the SpaceX hard landing, an upcoming eclipse of Alpha Comae Berenices, Beagle 2 found a false alarm on the ISS, the engine test of the new SLS boosters, a Milky Way spiral alarm that goes all the way around the galaxy, quiet pulsar, measuring Saturn, and then a bunch of other stuff. So let's get cracking. What do I want to know about first? I want to know about the SpaceX hard landing.
Yeah, so this was our big news last week as we were waiting for this launch to happen, and it finally did happen on Saturday morning. The Falcon 9 successfully delivered the Dragon capsule to the International Space Station with all of its equipment on board, and then it attempted to land the first stage of that rocket on a barge floating out in the Atlantic Ocean. And initially, SpaceX CEO Elon Musk said that they were close but no cigar, and didn't give really any more information than that. But over the course of the week, more and more information has been trickling out. First, some pictures, and then most recently, an amazing video of the rocket coming down at an extreme angle, about 45 degrees, smacking into the surface of the barge and exploding. And this is a really big success because they hit a tiny target, 100 meters by 100 meters target in the middle of the ocean after delivering cargo to space. That alone had never been accomplished before. And the point of failure here was one that they hadn't really anticipated, not surprisingly. And that was with the hydraulic system that moves basically the fins of the rocket to help steer it. And most hydraulic systems, like the one in your car, for example, are what we call closed systems. That means that there's liquid in the hydraulic system that's being pushed by a pump used to actuate various things. But when that fuel pushes against the valve or whatever it is that it's moving, it then returns to the system and can be reused again. That's why our cars aren't constantly leaking fluid everywhere we drive.
Right. If they are, you need to get that fixed.
Right. Mm-hmm. The thing is that those kinds of systems are pretty bulky. So SpaceX had opted for what's called an open hydraulic system, in which after the fluid does what it's going to do, it basically is just vented off. And you don't need all that extra piping to return it to the pump. It's lighter, and light is good when you're talking about a rocket. But landing on the barge took a little bit longer than they expected, and so they actually ran out of this hydraulic fuel, which is what caused the rocket to tip over right before impact. They needed just basically another minute's worth of control over the rocket in order to get it right where it needed to be. It didn't have that, and as it came down, it started tipping over. So when they plan to do another test of this system about 2 weeks from now, they've loaded it up with substantially more hydraulic fluid. So it's still going to be an open system, but they've given it several more minutes of flight time before they would have this kind of failure again.
And so if they had enough of that hydraulic fluid, it probably would have been a successful landing. Or something else would have messed up.
Right. So Elon Musk tweeted out after he released this video saying, "We've given it more hydraulic fuel. Next time it will blow up because of something else." So that's the attitude that they're taking, is that this was the first problem, and they're going to play whack-a-mole, and they're going to stamp this problem down and see what the next problem that they encounter is.
Yeah. Now, I don't know if people are aware of this, and the math is still up in the air, but SpaceX is going to be launching somewhere between, if you go to their website, I counted 16 rockets, Nancy counted 17, someone else has counted 14. So they're going to be launching more than a dozen rockets this year, plus they're going to be launching the Falcon Heavy.
Yeah, that's right.
So test launch of the Falcon Heavy rocket.
Something what we were expecting, but they did announce that they would have a test launch in the first half of the year, probably sometime towards the beginning of summer, of the Falcon Heavy, which will be their sort of competitor to the Space Launch System, designed to launch heavier payloads into orbit.
Yeah, it's going to be the most powerful rocket since the Saturn V.
That's
they're
correct.
They're testing the barge landing in just a couple of weeks again. They're going to try it again. So.
Yeah, I think it's 2 weeks from yesterday.
Yeah.
Is the nominal date.
An interesting thing, that morning when they launched on the first orbit here in northern Maine, it was just coming up on sunrise, and I was out watching with binoculars, and I saw the S2, the Falcon S2, and the Dragon, and the 2 solar panel covers as well come up here over northern Maine. That's something I had never seen before. I'd heard other people talk about it, if the orbital geometry is just right. So we saw them as 2 bright stars and 2 faint stars, but they were all, I wish I had my camera out there. I didn't think they were going to be that bright. Bob King over in Minnesota said a bunch of people saw it. They said it looked like there was a cloud around the S2, and I think there was some kind of venting or something going on when it came over, when he saw it. So I was like, it was kind of interesting to watch for. I had never seen that before.
Well, I look forward to us continuing to report on this, especially when it starts to get boring. Like, once again, this is the 14th time that this specific rocket has landed safely at Kennedy Space Center, and they've decreased the reload time to 3 days. So, okay, let's move on then. So, Dave, you've got... Actually, let's talk about the Beagle too, David.
Yeah, today there was all this controversy swirling around the internet a few days ago as the European Space Agency said they were going to have a press conference today, early this morning, as a matter of fact, on Beagle 2. Now, if anybody remembers, Beagle 2 was lost on Christmas Day 2003, and thus far, all searches for any kind of debris or wreckage they had searched before initially with the Mars Global Surveyor at that time, a year or two after that, and the thinking was at the time was that the parachute or the airbags didn't deploy, or something had happened between when Beagle 2 was released and its 6-day descent once it went down and re-entered and tried to land on Mars. Had it had landed, of course, it would have been the first time any other country other than the United States and NASA had landed. NASA's actually had a pretty good track record landing on Mars. They've done 7 landings, and they've only lost one, was Mars Polar Lander. They lost back in '99, I believe it was. But the news that came out this morning was kind of interesting because they imaged the area. We kind of figured that it had something to do with the Mars Reconnaissance Orbiter and HiRISE because it has the goods on it, as a half-meter size camera on it, which is the equivalent of having a spy satellite orbiting Mars. It's usually the kind of camera you'd find on a DoD satellite orbiting Earth. So it has the kind of resolution that can be sub-meter resolution. Beagle unfurled was about 2 meters in diameter. And the images they pulled back actually do show that it looks like Beagle 2 had made it to the surface and at least partially deployed. It kind of opens like a pocket watch. The idea that it was like a meter-sized dish, and then it was going to open in these, I believe it was 5 separate panels. It was solar panels. There was no RTG on Beagle 2. It was just a solar-powered, solar-paneled satellite or lander. And it looks like it may have deployed. So it's kind of heartbreaking when you think about it that really it probably did deploy, and it's something like either it got jammed up against a rock. This is me just speculating now. They don't know. They didn't say today as far as why they don't think it fully deployed. It might have jammed up against a rock or a crevasse, or it might have been a mechanical problem, or who knows what. But it may take a Mark Watney someday to walk over to Beagle 2 and take a look at it, dust it off, and say, "There's your problem right there. That's what's wrong with it." You know, somewhere this story may still be written. That's what's kind of interesting about it, though. You know, a couple decades or so from now, this story may come up again when somebody walks over to Beagle 2 and takes a look and sees what happened to it. But I think it's interesting because this was 11 years ago, and we're just getting these images now. So it was kind of interesting that this I actually wrote a science fiction short story about Beagle 2 too. So that's the story kind of when I saw it. I was like, I asked Nancy, can I write this one? Can I write this one? It's like, sure. So I was like,
Right.
It was very cool. It's very cool that, and I remember back in 2003. I mean, think about, we were all sitting there on dial-up trying to find out what happened to Beagle 2 back in those days, 11 years ago. This is pre-Facebook, pre-Twitter, pre-smartphones. You know, it's amazing to think about. This story is still ongoing.
I think one of the saddest parts of this story is that Colin Pillinger, who was the sort of head of the whole program and had really been its big booster in the UK, passed away just a couple of years ago.
He passed away last May. Last year. Yeah, not even a year ago. And he had searched imagery before from Mars Global Surveyor for Beagle 2 as well. There is a call out on Twitter to call the landing site for Beagle 2 Pillinger Station now too. So
that sounds great.
So.
That's a great idea. Yeah. Well, we can close the book on that mystery.
Maybe until somebody walks over and looks at it.
Right. All right. Well, Brian, Koberlein, let's talk about perhaps one of the Milky Way's arms does something quite unusual.
Well, something somewhat rare, yeah. This was a new paper that came out, I think, in Astrophysical Journal, and basically they were mapping. There's a team that's mapping the galaxy, and normally when you map the galaxy, you're mapping it with neutral hydrogen. So there's something called the 21 centimeter line that is pretty good for getting through all the dust and gas and everything, and it's a pretty clear signal of atomic hydrogen. And so when you look at where that signal is coming from, you can tell where the atomic hydrogen is. That's typically where the spiral arms are. The one big downside about it is that the signal from atomic hydrogen, from neutral hydrogen, is actually fairly weak. So you got to have a lot of atomic hydrogen in order to see this signal. So what this team did is they looked at radio signals from carbon monoxide, which isn't nearly as plentiful, but has a much brighter signal, and so it's easier to see. And what they found was that there are clusters of clouds that seem to follow an arc, and if you trace an arc of one of the spiral arms, Scutum Centaurus, I think, if you trace the arc of that, it seems to line up with those. And so what it looks like then is, you know, if you've got the Milky Way, here's the center, and the spiral arm of Scutum Centaurus starts here, and it goes all the way around at least to about here. And then if you look where these new clouds are, it goes more than 360 degrees around, so it spirals out more than one turn. And that's actually pretty rare. I think it's like 1 in 20 might have more than a full turn on their spiral arm. The one thing is, where they found it, there's still a gap between what we've seen with atomic hydrogen and some carbon monoxide and where they have this now. So it may be an outer arc that's disconnected, but right now it looks like it's a continuous spiral arm.
That's really cool. I hadn't heard the percentage, so the fact that it's about 1 in 20, that makes it pretty rare.
Yeah, it's like 5% or something.
Now, is there something that can cause a long spiral arm like that?
That's a good question. We don't know. At least
Great.
I don't know.
Great. Well, I'm glad I'm asking the good questions. I'm going to take a couple of comments here from the audience. So if you're watching this and you want to ask us a question, go ahead and use the Q&A app, which is, if you're watching the video, it should be a link there, and you can click that link and it'll bring here. So Jim Meeker is noting that a video of the SpaceX booster landing can be found on the WSH crew community on Google+. So yeah, I didn't include the video because if I included the video, then this video would be pulled down for copyright violations, because I had included a piece of video that had also showed up in some Brazilian television station, and they had claimed credit for it. So that's exactly what happens when I include video from NASA. You name it, it causes me problems. So I just don't bother. But yeah, so and actually this is great. I will plug the WSH crew. So that is the Weekly Space Hangout crew. These are the dedicated fans to the Weekly Space Hangout, and you can find that as a Google Plus community on Google Plus. Just search for WSH crew.
The video is totally worth seeing. It's
totally worth seeing. Yeah. Yeah, I showed you the picture of it actually reaching the deck. Tom Nathan is saying, too bad they couldn't swap out the Beagle's batteries. I would think the electronics are okay. So yeah, so in I guess a future Marstronaut can show up, swap out the batteries, and get that spacecraft rolling again.
After being cold for so long, probably a lot of the electronics have been irreparably damaged. Not to rain on any parade here, but after being on the surface for more than a decade without any sort of heat, they're going to be in, not the world's best shape.
Mark Watney did it with Sojourner.
Yeah.
Well, we can't all be Mark.
Okay, well let's move on. So next up, let's talk about the test of the SLS booster.
Yeah, so that was this week was the first test firing of the new SLS rocket engine, which is called the RS-25, and is actually the old Space Shuttle rocket engine, main Space Shuttle engine. And unlike the Space Shuttle, which had 3 of them, future SLSs in general will have 4 of these engines on board to help provide thrust. And they've had to make some modifications to the Space Shuttle engine in order to accommodate that and accommodate other technical problems. Like there's going to be a lot more fuel in the SLS than there was in the main Space Shuttle fuel tank, so there's going to be higher pressure on the valves and things like that. And so this is the first step towards moving SLS forwards to actually being able to launch in 2018, which is the planned first test launch, I believe, of the SLS. And what's interesting is this is not the first time that we've kind of thought about using the Space Shuttle engines again. The old Constellation program that was proposed under President George W. Bush and then canceled by President Obama to be replaced with the SLS also had the idea of using the Space Shuttle main engines because we have a bunch of them left over from the Space Shuttle program, and we can use those to get basically a few free rockets, if you will, before we have to start manufacturing new engines for future launches.
And so just for people who maybe are sort of trying to imagine this in their head, right? If you look at the Space Shuttle, you've got the solid rocket boosters which are on either side of the Space Shuttle, the big orange fuel tank, and those are different engines. Although the SLS is going to have those as well, and then it's the liquid rockets that were down at the bottom of the Space Shuttle, right?
Right. If you remember the Space Shuttle looks like, there's kind of 3 cones in a triangle at the bottom, and fire comes out of those cones, and those are the main Space Shuttle engines. And those cones can move to help steer and balance the shuttle as it was lifting up. And that's what we're being reused. And they're truly enormous. Each one of those cones, would probably not fit inside of your living room. They're huge, and we're going to put 4 of them at a minimum, I believe, on the SLS, and perhaps up to 6 in some future large variants of this engine. And that's going to give the Space Launch System lifting capacity beyond the Space Shuttle and beyond anything else that we have built.
And I mean, with it's also, as I said, it's going to have 2 of the solid rocket boosters in addition to this, the liquid ones as well. So it's going to be able to, as you say, lift just an enormous amount into space.
Yeah, I think it's 130 metric tons is the baseline lifting capacity of SLS, and that's more than twice the capability of any rocket that we have active right now.
How does that compare to the Saturn V? Do you know what the launch capacity
is? It's similar. The large end SLS will be larger than the Saturn V, or heavier lift than the Saturn V, and the lower lift SLS, I believe, will be a little bit lower than the Saturn V. So there's going to be a range of various rockets eventually to meet various needs, and those will have some varying numbers of engines, number of solid rocket boosters, and ultimately a variety of lift capacities.
And what are the kinds of missions that that will NASA be using this system for? Because they're still going to be purchasing SpaceX launches, they're still going to be purchasing probably Delta and Atlas launches, but what will they be using the SLS for?
Right, so the first idea is that we're going to go to an asteroid. And we're either going to study that asteroid in place, or we're going to somehow capture that asteroid and put it in orbit about the moon, where we can study it. SLS has also been thought of for going back to the moon, possibly in the far future, 20 so years from now, going to Mars. And it could also be used if we ever wanted to lift additional components up for the ISS, or work on building a future space station, say at the end of the ISS program. Those are the sorts of things that require very heavy launches that we wouldn't be able to do with any existing boosters.
Right. Very cool. I was trying to share a picture and it just wasn't working. So imagine a kind of crane-like structure with a gigantic plume of smoke in the night. That's what you can see. Just imagine it in your brain. It's an awesome, truly awesome picture. I highly recommend you go to universetoday.com and you can see this and all your handy space news. All right, let's move on. I'm going to talk about... So David, you kind of dug this out, and we've been making a big deal about this on Universe Today, and this is that there's a rare eclipse, a 1 in 26-year event.
Yeah, this is an eclipse of what's known as a binary star. These are mutually eclipsing stars, kind of like you think of the star Algol as probably the most famous eclipsing binary, Alpha Persei. But unlike that, where it eclipses every couple of days, this one is thought to eclipse once every 26 years. Now, back in 1989, we know that the orbit of this star is Alpha Comae Berenices. We know that the orbit of this star is inclined almost right along the line of our sight. However, back in 1989, they never caught the eclipse back then. So there's a lot of discussion of whether it's a central eclipse or if it's inclined just 0.1% out of our line of sight, we would actually miss it. But there's actually, I caught this in Sky and Telescope in the January issue, and there's also an alert out right now on the AAVSO, the American Association of Variable Star Observers, for amateurs and professionals to get out there and try to monitor this star. The key dates that they're looking at right now are from January 22nd to 28th. We've got the orbit a little more refined than we did back in 1989 because we've got better computing power than we did back then. And what we're hoping to see is, if it's a central eclipse, maybe the dimming of the star by about 1 magnitude. The star is a 4th magnitude star. It rises right around local midnight right now in January, so the best time to start observing it is in the morning. And if you've got a DSLR, there are people out there that do photometry with the DSLR and downloadable software that you can get. We linked to a PDF that the AAVSO put out that shows all of the methods that you can use to actually do photometry with your DSLR. Or you can do it the old-fashioned way, the way I've always done it, is you're looking at a variable star, you're just looking every night, and you're measuring. That's an artist's conception of the pair. You're looking and actually comparing, like saying it's brighter than this star, fainter than that star, about the same brightness. You're looking at other stars in the field that are of known magnitude, and you're looking to see. Now with this one, it's not like an asteroid occultation or anything. You're not going to see an abrupt dimming. They're thinking the dimming is going to be over the span of anywhere from a few hours to 48 hours. But this would be interesting because this would be the longest eclipsing variable star known if we actually could identify this as an eclipsing variable. Somebody brought up in the comments, and something I had researched and thought about when I read this too, is like, well, what about Epsilon Auriga is another famous eclipsing variable. It's like, well, that is eclipsing because there is a debris disk around the alpha primary. These are actually physically eclipsing variables, but that one has a time scale comparable to this one, about 27 years. This one is 26 years. But this one would be the two stars actually physically eclipsing. And Kepler uses the same type of method to look for exoplanets, and the TESS Space Telescope is going to use the same method. So this is something that's interesting that's out there, and it's a place where amateurs can contribute to real astrophysics.
And we don't know exactly the period, right? And so what's great about this is that amateur astronomers are going to help really nail down
this will refine
specifics of it.
Yeah, this will definitely refine what we know. We know it's in roughly a 26-year with some change period on it. The maximum separation on this pair, even when they're at their furthest apart from our line of sight, is not even an arcsecond. So they're a challenging double, even on the best of years when they're actually separated. Of course, you're not going to see the pair separated when they go to eclipse each other. They're F5 type stars that are both fifth magnitude each. So you're definitely not going to see them separated apart. But it's going to be an interesting challenge to get out there. And of course, this is January too.
Yeah, but would a fairly powerful telescope be able to distinguish them?
They could distinguish their spectra. They would be what's called spectroscopic binaries. They could see the two tangle of the two spectra, and there are some doubles that's the only way we can tell they're doubles. But you're not going to be able to resolve. I don't even think Hubble would be able to resolve these. They're just too close when they're at closest approach. When they're at furthest apart, yeah, 0.9 arc seconds is difficult, but not too hard for something like Hubble.
Right. That would be interesting to see an animation or a time lapse of the stars.
There are some double stars you could actually live through their orbit. A few weeks ago, we wrote about Sirius and Sirius B and the challenge of trying to spot Sirius B, and that's in a 50-year orbit. So you can conceivably Sirius B is reaching its best visual separation from Sirius A toward 2020. So. We started writing and trying to get people out there to, if I've never seen Sirius B because it's so much fainter than its primary, but the time frame in our lifetimes to see it is coming up in the next few years.
That's really cool. So if you've got a telescope and you want to participate in this, how can I guess people should just come and read the article, but where should they go? Should they go to the WAVSO to?
Yeah, they've got an alert notice up there. We've linked to that, and we've linked to the whole observing campaign. This star is bright enough, fourth magnitude. You can see it from a dark sky site too, so you could conceivably make estimates with binoculars or even the naked eye and just look at it. We put a finder chart up there with comparison stars, so you can do, like I said, the old method, the old 19th century method of just sitting there and like comparing it, saying a good visual observer can actually discern down to about 1/10 of a magnitude. Some observers are pretty good at sensing those changes. 1 magnitude is about 2.5 times in brightness. Is the change in brightness, so that's noticeable with the naked eye.
That's really cool. All right, let's move on. So, Brian Koberlein, let's talk about this pulsar that showed up, delivered a whole pile of data, and then disappeared again.
Yeah, this is a binary pulsar, and it's orbiting another star that could be a neutron star or could be a white dwarf. We're not really sure, but it orbits with a period of a few hours. So these are really close binaries. If you calculate how far away they are, their separation is about the diameter of our sun. And so you have these, two Earth-sized but star-massed objects that are orbiting, the width of our sun apart. And one of the things that happens is that because they're orbiting, you can get precession. You can get that because of the gravitational pull between them, the axis of the poles, their axis of rotation, will shift over time. And so what happened with this particular pulsar is pulsars are neutron stars that kind of sweep out a beam of energy, and we see them as pulsars when they're sweeping in our direction, like a lighthouse. But we don't see them if they're not sweeping in our direction. So what happened was this particular orbiting neutron star slowly precessed to the point where its beam of energy due to its magnetic field was pointing in our direction, and we could start seeing it. So you can take measurements of this thing, and then it kept precessing, and it precessed so that the beam shifted out gradually, and it faded away. The interesting thing about this is that they were using the data to study a test of general relativity. How do their orbits decay over time? But they also got data because of the precession of the general relativistic precession as opposed to this standard Newtonian precession. And so they now have data to look at that too. So it was kind of just a happenstance where it lined up and then went away.
Right, and it's only been observable for just a couple of years, right? Like maybe 5 years.
Yeah, a couple of years, and they had a radio telescope array. They took, I think, on the order of 1 million observations. So they had an array. They were watching this thing continuously.
Yeah, just in a minute. That's really, really cool. Thanks, Pulsar. Maybe we'll see you again someday.
Yeah, I think it's 2160 or 2260, something like that. It should precess back.
Right. Okay.
So, I'll be my third
Be
robot.
patient and hang on.
So Morgan, we had a scare on the International Space Station 2 days ago.
Yeah, back on Wednesday. It was a
Wednesday morning.
scary moment when one of the environmental alarms went off at 4 a.m. Eastern Standard Time, suggesting that the atmosphere was being poisoned by ammonia gas. Now, this was the middle of the workday, actually, for the astronauts, so they weren't roused from their bed or anything. But they had to slap on some emergency oxygen masks and flee to the Russian side of the space station, where they could seal it off and wait for further tests. And it turned out that this was just a false alarm. A sensor or a computer that controlled one of these sensors had some sort of malfunction. And mission controllers took about 12 hours to fully determine that there wasn't any abnormal level of ammonia in the atmosphere. And they were worried about ammonia to begin with because this is one of the primary coolants used aboard the space station. It's kind of a counterintuitive thing, but it's actually really hard to cool down in space. You're much more worried about overheating than you are about freezing in most instances in space. And so they have to use a lot of cooling systems, and ammonia happens to be one of the most efficient coolers for that. But it's also very corrosive against the human skin. You wouldn't want to breathe it in or have drops of it fall on your hands or your face. And so they're constantly monitoring the atmosphere for this.
Yeah. Like that's what they used as poisonous gas in World War I, right? You mix, was it ammonia and bleach together, and you get like, mustard gas?
That is actually toxic, yes.
Yeah.
So this is not the first ammonia. There have been actual ammonia leaks on the space station before, but they've always been external to the crew cabin. But these procedures are in place. First they could flee to the Russian side, which is what they needed to do this time. But if it was clear that the leak was more widespread, they can always flee into the escape modules, which are the Russian Soyuz capsules used to transport these astronauts to space. So they have a number of precautions that they can take to solve these kinds of problems. And in this case, it was really just be patient and make sure that everything was okay.
But I just wonder what would be involved if there was an ammonia leak. Cleaning up the ammonia on the space station would be just miserable work. I just can't imagine how they would actually do that. I mean, they'd probably have to have some special cleanup gear, and they'd have to send a crew of astronauts with with their spacesuits they'd have to wear or some kind of special environmental suits, and they'd have to clean it up.
Yeah, you might be able to just vent the interior of the station to space, and all the gas would vaporize and be carried out, but it wouldn't be the kind of situation that you'd want to have to deal with. And there's a good chance that in that sort of instance, they'd have to bring the astronauts home and make sure everything was safe before they could let them, go back up and live in space again. And we've now been, continuously in the ISS for 15 years, and it would be a big blow to that program if you had to bring them home, even on a temporary basis.
Well, and there's long-duration astronaut tests that are just coming up. There's going to be some astronauts that are going to be up there for a whole year, and there's going to be a series of these from this point on. So now we're moving into these long-duration experiments with astronauts. They just sent up a bunch of crazy stuff to the space station just a couple of days ago with the Dragon capsule, and they included a bunch of worms, which these worms have been up there a million times, but they're going to be they're the ones that survived the C. elegans, are the ones that survived the Space Shuttle Columbia disaster. So they're very tough worms, and they're going to be testing.
It was interesting how quickly this made the mainstream news. Within about 10 or 15 minutes after I saw it on Twitter, it started being reported on CNN and Fox and everywhere else. It was an interesting study, even though it was a false alarm, how quickly, since they had the whiff of a disaster or potential disaster, it made it right up there in the news.
Yeah, absolutely. We were pretty careful. I think originally on Universe Today we had posted that there was an ammonia leak on the space station, and then I think later on we modified our article to be there was an ammonia leak alarm on the space station. So, because that's it was pretty clear that that's all there was so far. Good. Well, I'm glad they're safe, and business as usual. Interesting anecdote. I got to explain the structure of the International Space Station to William Shatner via Twitter 2 days ago, which was pretty great. He wasn't aware that the space station had a Russian side, and so I explained all the modules to him. So that was my brush with greatness. Yeah, he'd know. Okay, so Dave, let's talk about the upcoming asteroid.
It's something I've been monitoring, and Bob King wrote an excellent article about it. I just read on Universe Today. We have a near-Earth asteroid passing the Earth on January 26th. This is 2004 BL86. And this is going to be one of the largest close approach asteroids until 2027, when 1997 AN10 passes within 1 lunar distance. Now, this one's only passing within 3 lunar distances. It's 680 meters in size. You know, it's a respectable size. But the interesting thing from an amateur perspective, it's going to reach about 9th magnitude, and it's going to be pretty well placed for North American observers, actually, going up through the constellation Cancer, right about the closest approach, right across the ecliptic. It's got a high inclination, so it's going to be coming right across the ecliptic, and it's actually going to pass right in front of the Beehive cluster M44, which is going to be kind of, I'm fully expecting to see some animations of that to come out. M44 is going to have another 9th magnitude star, and this is going to be moving. It's going to really be trucking at 2 degrees per hour. That's 4 times the size of a full moon per hour. So when you're looking at it through a telescope, I saw Tutatis like this a few years ago, and you could actually see it moving, kind of like a very slow-moving satellite when you're watching it. But you could actually watch it, and over the span of a minute or two, see the actual movement, which is something you don't usually get from asteroids. And there's going to be a fair amount of parallax involved with this one, too, because it's passing so close. Incidentally, building star charts, I got to commend Bob on doing this, because building star charts for really close near-Earth asteroid passes, you have to also take into account the parallax, meaning that where you're observing it on the Earth is going to be slightly different in the sky. And you also have to take into account the fact it's passing near Earth's gravity well, so that's going to change its orbit. A lot of planetarium software programs don't account for that, so they don't account for the deflection that's going to occur. When it passes near Earth, it's going to slightly... This is no danger to Earth, incidentally. 3 lunar distances is still quite a ways away. But it's going to be interesting to see. I'm going to try to get out there and probably see it. 9th magnitude, like I said, that's in binocular range. And I always thought, too, we need some other way to, because all the news articles, of course, are going to start describing it as aircraft carrier size, building block size, all these different things. You know, we need something, you know, battle star size, Death Star size. You know, we need to get some other good size comparison things for these articles, because it's getting a little old to keep repeating the same. I'm trying to think of something. I don't know what.
Manhattan. Size of Texas.
I'm thinking 680 meters. I'd have to look it up. That might be Battlestar sized. I'd have to look it up. But I think that's smaller than Death Star size. But,
oh yeah, no, the Death Star is hundreds of kilometers.
More like series sized, I think.
Yeah,
so.
I think the Death Star is 120 kilometers.
Yeah. So,
I can't believe I know that. No, actually, I just did a script on whether the Death Star could destroy the Earth. So that was why I know that number.
Sure.
That'll be coming up in about a month and a half for one of our videos. Good. Well, it was safe, and I think this is the closest it's going to come in 200 years.
For this particular one, yes, closest in 200 years. And you know, we could always have another near-Earth asteroid pass. Every year we have at least a dozen of these to report on, of smaller ones that come within a lunar distance or so. So, well, but this one's going to be an interesting one to watch. And it's one. Remember, last time we had a near-Earth asteroid coming to pass was the same time that we had the Chelyabinsk incident happen. It was the same day. So if we have another Chelyabinsk happen the very same day this one passes, we'll have to be putting up more, recycling more explainer posts on how they're not related. It's not the same thing.
No.
Get your dash cams ready.
Yeah. So, Brian Koberlein, it turns out that we had no idea where Saturn was for hundreds of years.
Well, yeah, on the order of a kilometer, yeah, we had no idea.
I got to admit, I stole that title from
This is
IO9.
kind of an interesting thing. What they had a radio telescope array, and they used it to look at the Cassini mission, and they actually used parallax in this case, which is really kind of interesting. But they took this array and they measured where the position of Cassini was relative to quasars. And the nice thing about quasars is quasars are so distant that they're basically stationary points in terms of radio signals. So you can use them to mark the position of something relative to a different radio signal. And because of these large radio arrays, you can get an astounding level of precision. So what they did was they measured where Cassini was at different times relative to these quasars, and they got the orbit of Saturn to within plus or minus about 2 kilometers, about a mile, which is astoundingly accurate. You know, it's one of these things where you can't get that accuracy unless you actually have something there. And the reason why this is useful is because if you can do it with Saturn, you can do it with Jupiter. You can use it for the type of things if you want to land, for example, a probe on a moon that doesn't have an atmosphere, because then you can't brake. You have to actually use fuel to land there softly. So if you want to go to Europa, we got to know this for Jupiter.
All right. Yeah, I mean, knowing how to get those spacecraft, I mean, to have a really accurate flyby and trajectory is super important. So it seemed very frivolous, you know, like, oh, now we know it.
Yeah.
1 more kilometer. But actually, you can save yourself a ton of fuel and really make your orbital insertions. When you think about the JUICE mission, which is going to be coming up in 2022, and they're going to be doing flybys of Jupiter, flybys of Callisto and Europa, and then actually go into orbit around Ganymede. And so that's very, and that's and that's Jupiter, and that's a great example, right, of them having a very complicated series of orbital maneuvers that they're going to have to do to get the most of that spacecraft to have it actually make that final orbit around Ganymede. So you can imagine the same thing, you know, being able to do those kinds of flybys and orbital insertions to Saturn. It's very important to get this level of precision. So I wonder if they're going to update everyone's software based on this new
it's
knowledge.
A recalculation of the ephemeris, so I would assume so.
Okay, so let's go, and we're gonna take some questions, some posts, some stories that have been proposed by the folks from the WSH crew. I'd mentioned this before. This is the weekly Space Hangout crew, and they all week long post all kinds of really cool ideas and stories and stuff that we missed. And so I thought we would just take a few seconds and talk about some of these stories. So first, this is a story that comes from Tom Nathy, and this is about a meteorite, what appears to be an ice crater in Antarctica that's been discovered.
Maybe. So the crater's there. It's real. This was spotted serendipitously by a small aircraft flying over, research aircraft flying over northern Antarctica, and it's a crater about 2 kilometers in diameter, and it looks a lot like a crater. That's about twice the diameter of Meteor Crater in Arizona, for reference, and it looks a lot like the sort of crater you'd expect to find from an impact. And some people originally thought that this might have to do with the 2004 meteorite that was seen over Antarctica. But by going back and then searching satellite imagery of Antarctica, scientists have found this crater going at least all the way back to 1996.
Oh, wow.
So it was not connected to the 2004 incident, but there's plenty of meteorites that hit every year that we don't know. The real problem is that a meteorite that would create a crater of this size would probably be about 200 meters across. It's usually about a 10-to-1 ratio between the size of the crater and the size of the thing that makes the crater. And that's about 10 times bigger than the meteor that blew up over Chelyabinsk about a year ago now. And so this would have been a tremendous explosion. Possibly something that we wouldn't have missed from, say, satellites out there to enforce nuclear test ban treaties, or also the size of an impact that would have severely damaged the ice. And we're not talking about smacking into rock here. We're talking about an enormous fireball in the middle of a sheet of ice. So it's not clear that an impact of that size would produce a crater as seen in Antarctica. But if that's not the case, there's not a good explanation for what else it could be. One possible thing that creates crater-looking structures sometimes is the bursting of gas pockets underneath the ice. This commonly happens in, say, Greenland with methane. Methane gas is trapped underneath the ice. It finds a way to either escape, causing the ground to sort of sink down into where that hole was, or it explosively bursts outwards when the pressure becomes too great. But for that to happen on a 2-kilometer scale would be a truly remarkable gas incident. And so that's difficult to sort of imagine as being the cause for this as well. And so really we have kind of a whodunit here. It's been 19 years now that this guy has been there, and we don't have a good explanation tying any particular source to the formation of the crater.
I anticipate further missions being sent to this location in search of either evidence that it's a gas pocket or debris from a meteor. I mean, they've only seen it from the air so far. They haven't even.
I believe so.
Yeah, so they haven't even landed to check it out yet and look for chunks of rock.
I
Okay,
volunteered
cool.
to lead the Universe Today expedition down there. So.
Do you? Oh, okay, great. All right.
We're already
what
training
else
in Maine.
Yeah, I'm already Arctic trained, so.
Let's see. What else do I find really interesting? What else is cool? Okay, so we can talk. This one comes from. This also comes from Tom Nathie, and this is about the world's most powerful digital camera has received funding approval. I don't know if you folks have been watching this. It's the
LSST, ain't it?
Yeah. So the new LSST telescope.
I just saw the LSST mirror in the mirror lab in Arizona. They're finishing it. There's a photo Nancy put up there of the same thing. It's interesting. It's actually got 2 focal planes carved into it. I had never seen a mirror like that before, but when I was touring, it's like they said that's the LSST mirror there. And it's like, oh, cool. I think it's going out in 2020. It's going to see first light. It's not coded yet. They're still inspecting it, but it was kind of interesting to see them actually figuring the mirror and stuff, thinking of like amateurs, what they have to do to figure small mirrors. I can only imagine what they go through with those kind of mirrors to actually coat them and do everything they got to do.
And the image of it is great. I'm just going to find the. It's so some interesting things about the LST. One is, it may be a telescope, but it also looks like the Earth defense ship.
Yeah.
So I don't know if I can actually pull a copy of the image out, but the actual building that this thing's going to be housed in just looks like this. I don't know, Star Blazers.
They're going to be generating petabytes worth of data too. I mean, that's beyond terabytes. They're actually it's actually going to push back a lot of data storage techniques just to even. And you think about that's going to be stuff that amateurs can all comb online. I mean, you think of what people are doing with Galaxy Zoo and stuff like that now. I mean, there's probably going to be a lot more discoveries just coming out of that data as well. Comets,
3,200 megabyte digital camera, megapixel digital camera. So it's a 3.2 gigapixel camera.
I believe what they're using on Pan-STARRS is the biggest right now, so that's an operation. So that's going to blow that away.
And so it's going to take 800 panoramic images every night, and it'll cover the sky twice a week. Which, when you at a tremendous level of detail, when you think about things like the Sloan Digital Sky Survey, it's going to be able to do Sloan Digital Sky Surveys every couple of weeks. It's amazing.
You're going to see a lot more comets named LSST probably. Like
exactly. Yeah. No, this is great because I think people, and I would love to get someone actually. Let's do that. Let's get someone from the LSST project involved, here, because people don't realize just how much of the sky changes, and it's only when we start to have these observatories like the ones that search for gamma rays that are imaging the sky, and they're sensing these objects, and they're turning to watch these gamma ray bursts. There's a lot of stuff that happens in the infrared and in the visible light that's changing all the time, and so you're going to have these, they're going to be finding asteroids, comets, variable stars, eclipsing binaries, all kinds of things just by changes in brightness in the sky. So this is going to be an amazing project. Cool. All right. Well, I think we should probably wrap things up. There's a bunch more stories, but I don't think we have time for any more. So let's talk about ways that people can find more about you guys. So Brian Koberlein, where do we find out more?
You can find me on my blog at briankoberlein.com. You can find me on Twitter at Brian Koberlein. You can find me on Google+. It's a rare name, so it's easy to find.
Yep. Dave Dickinson, where do we find out more?
See, this week I was active on Canada.com, Listosaur, Universe Today, and I'm currently offering up selections of free fiction on Astro Guys. Nice. Actually, the story I'm running right now is The Hunt for Beagle, which I'm probably going to have to rewrite now they found Beagle. That's actually about a student that decides to find Beagle for her science project in the future, a future Mars colonist. It's a young adult story. And I also have a new solar wind story up on my author page, and David Dickinson on my Amazon author page as well.
Perfect. And any, just like Andy Weir, any science fiction folks want to sort of notice that, they can come and yeah, and they can find your story. They can Ridley Scott will direct your movie, The Search for the Beagle.
Anybody wants to make Solar Winds or Hunt for Beagle into a movie, that would be great.
Awesome. Morgan, where do we find out more?
Well, right after the show, I'll be over on the Google Plus Space community, taking any of the questions we didn't get a chance to answer, talking about some of the stories that we didn't get a chance to cover. If you're in the Denver metropolitan area, you can come out tonight to Fisk Planetarium and hear me talk about NASA spin-off technologies. And otherwise, you can follow me at Morgan Rehnberg on Twitter.
Fantastic. Okay, and once again, I'm Fraser Cain. You can find me fcain on Twitter, right there. And of course, we've been publishing lots and lots of great videos on Universe Today. So you can, let's go. Say hi. Yeah, so we'll be publishing lots and lots of videos on Universe Today. We've got we just recorded another batch this week, like I said, including Can the Death Star Destroy the Earth? Yes, because it's a story. Yeah, and so by all means, follow me on Twitter, follow me on Google Plus, and follow us on YouTube where you can watch all these cool videos. Well, thanks guys for joining me this week. Thanks everyone for watching. We really appreciate it. I'm glad. Thanks Internet at the in New Orleans. I'm really glad it worked out okay. And we will see you all next week.